Hello friends, welcome back to today's video of Start Pro for fresh civil engineers. Up till now we have completed the analysis of single span as well as the continuous beam. Then we have completed the analysis of single story frame as well as the multi-storied frame. Now in today's video we are going to discuss the analysis of trusses. Now all of you are knowing that truss is a structure which is comprised of a triangular components or triangular members, where all these members are get connected to each other at the joints or at the nodes. There are various application of this truss. It can be used as a roof. Also in case of bridges, also the trusses can be used. Now the analysis of these truss members is quite difficult as there are more numbers, as well as it will be get subjected to or inclined members are also there. Hence by using the Start Pro you can easily do the analysis of these truss member. Also you can easily find out the forces in the truss members. So now in today's video we are going to discuss the analysis of this simple type of trusses by using the Start Pro. Now let's considering this simple triangular truss which is having a height of 3 meter, then inclined length of 6 meter, the horizontal span is 5.2 meter. It gets supported at A as well as at C and gets subjected to a horizontal or lateral load of 10 kilonewton at the point B. So let's start the analysis of this simple truss by using the Start Pro. Okay, so first of all in Start Pro this grid is there. Now considering the front view of this, so first I am adding a beam of 3 meter span, right? Now here as it is a 5.2 meter span, so for that purpose I am adding a node over here. So the horizontal distance is 5.2, y distance is 0, z distance is again 0. So that node is get added over here. Okay, so add the beam joining these two nodes, then again add the beam joining the node number 3 and node number 4. Okay, now just closing the grid view. So this is a simple triangular truss of 5.2 meter horizontal and 3 meter vertical height. Now here if you see the length of this 3, the inclined length of the beam number 3 is there, that is 6 meter. Okay, which is already given in the numerical, right? And then length of this beam is 5.2 meter as well as length of this beam is 3 meter. Okay, now next we have to go in a general and define the cross sectional properties. Now in case of trusses, the members of the truss or the cross sectional properties of the truss, it may be of concrete or it may be of steel, but most of the time the trusses are made up of steel material. So considering here steel and considering a T-shape angle sections, so here you can define the size of these cross sections. Let's say the depth is 0.35, then width is 0.2, then YB height 0.3 and ZB, that is nothing but the thickness. All these dimensions are mentioned in the figure so that you can easily mark it, let's say as a 0.05, that is nothing but the 50 mm, and the material is of steel. So add this cross section and close. Okay, even you can add the section from here, the section database also. So when you are clicking on this section database, then you can consider here the code, the Indian code, and then you can define the any type of cross section, that is nothing but channel section, angle section. If I am taking here channel section, here the different type of channel section sizes are given. You can take any channel section size. Let's say if I am taking this one, the material is steel and this section is get added, close. So you can define the cross section through this define tab. Also you can add the section through this tab. In case of truss, it is preferable to add the cross section size through this section database. So I am deleting this prismatic and now considering this channel section size, and here I am selecting assign to view, assign, yes. So all the beams are made up of this steel channel section. Now next is support. Now creating the support, there is one support, pin support, so add that support over here. Then one more support here, the roller support, so fixed, but considering releasing this fx and mz movement, add that support. So now support 2, that is pin support. Here select the node cursor, assign to selected node, assign, yes. Then select the support 3, that is nothing but the roller support, select this node, assign here, yes. So roller support is assigned over here. Then now next is load. So here load case details, add load case 1, okay, close. Now in load case details, add the nodal load in the direction of x, so 10 kilonewton in the positive x direction, so I am putting here plus 10, add over here and then close. So now assigning this load, assign to selected node, selecting the node cursor, assign to selected node, assign, yes, okay. Now you can decrease the size of arrow from here, put the labels of load value, so 10 kilonewton load is get applied at this point, okay. And now you can click on here, analysis and print all, add over here, close. Then perform analysis, select the whole structure, assign, then analyze, run analysis, save. Okay, so 0 errors and 0 warnings, done over here. Now you check the post processing, load case details, apply, okay. Now you can see over here the deflection curve of these truss members that will be appeared over here, right, in the z direction. Then here the bending moment diagram in the z direction, okay. Then similarly here this is the shear force diagram, y direction. Now you can see over here the reactions at the support, minus 10 kilonewton load is applied in the 10 kilonewton load is applied in the x direction, so here corresponding to that reactions at the support will be provided. So here this will be roller support, so only one reaction 5.769, and here hinge support, so two reactions, minus 10 horizontal and vertical is minus 5.769. Then similarly you can get over here, if I am selecting any particular beam, then property of that beam, loading, its shear bending on the deflection curve. So all these details will be available over here. Now here in shear bending you will came to know the value of the forces, reactions in that member. So here you can see when I am selecting this reactions and selecting the beam, so you will get here the reactions value in that beam. Fx reaction is minus 5.684, Fy is 0.214 and the movement is 0.579. If I am selecting this inclined beam, then the reaction forces value 11.317, then Fy 0.033, Mz similarly over here, right. Again for the next beam also you will get the values of reactions in that beam, right. So in this way you can analyze the truss by using the StatPro. Now let's solve one more problem of this truss analysis, considering this type of truss which is made up of 3 triangular components, okay, and get subjected to 10 kilonewton vertical load and 5 kilonewton again vertically downward load, and supports are provided at C and at E. The length is 1.8, 1.8, 1.8, 1.8. There are 4 nodes now, and vertical height is 2.4. Okay, let's solve this type of truss using StatPro. Okay, let's close this, open the new one, plain truss, second, next. Okay, now consider the front view. Now here again the distance is not the complete figure, so let's add the node with the help of this coordinate system. So first 0, then y is 0 0 0, next is 1.8, again y 0 0, next 1.8, y 0 0, next 1.8 0 0, next 1.8. So here 1.8 is the first span, 1.8 of second span. The total is span is 1.8 and 1.8, 4 times it will be there. So here 1.8 all at the 4 points, right? Then next coordinate is in the y direction. So here you can consider we are adding this line. Now we have to add the downward line, so I am considering in the downward direction, so minus 2.4, and in this side there are only two nodes, that is nothing but the x distance is 1.8, y distance is minus 2.4, and then the second one x distance is 1.8 plus 1.8 plus 1.8, and vertical distance is minus 2.4. okay, so here first at the horizontal 1.8 is minus 2.4 0 0, next is 5.4, then minus 2.4 0. okay, skip. So now let's switch off the grid view. 0.8, shift plus n, I will display the node numbers over here. Okay, so here the first node is 0 0 0, second is at a distance of 1.8, sorry, this distance should be 3.6, then this will be 5.4, and the last will be again 7.2. okay, then first node at 1.8 and the second node is at a distance of 5.4. just wait a minute, just check the figure. 1.8 plus 1.4, 3.6, the second node will be there, 1, here 2, then this one is 3, next is 4, and the fifth is again at 1.4, and here it is first 1.8, then 3.6 and 5.4. so 1, the last here it will be 7.2. okay, now it is correct. This node is extra one. okay, now let's complete the adding the beam. So let's join this beam, then 6 to 7, then 7 to 5, next is up to 3, then 3 to 5, here to 6, and then right. So this 2 and 4, these are the two nodes just we are providing for the purpose of applying the loads as it is given in the figure, right? So now you can check here, a load of 10 kilonewton and load of 5 kilonewton, those two loads are applied. okay, 10 kilonewton, 5 kilonewton, and support roller at E, pin at C. Okay, so here next we go in the general, go in the property. Again I will add the section database. Okay, selecting the Indian codes, selecting the, again I am selecting channel section of, let's say, size 350, material steel. Add, see, in case of analysis this cross sectional properties are not playing the role, but we know that when you are performing the analysis, then in that case if these section properties are not get assigned to the section, then it will not run the result, or there is a errors in the output file. So now here assign to view, assign. Okay, now next is taking the support conditions. So create here the pin support, add, then create the fixed part, fx and nz, add over here. So now first of all pin support, add, use cursor, 7, assign, yes, then select support 3, sorry, this support is at this, okay, I will just change it, support 2, selecting this support, delete, yes. Now again I will add this pin support, add over here. Now pin support is at point C, so use cursor to assign, yes, and then support 3 is at this 7, yes, right. Now next is the load case details. So add load case 1, add over here, close. Then in case of loads, here 10 kilonewton and 5 kilonewton, so let's add this load, a nodal load of minus 10, add, again a nodal load of minus 5, again add, close this. So assign the load, use cursor, assign to selected node, assign, okay. Then next 5 kilonewton, use cursor to assign, so here at 3. Now okay, you can display the load values, labels, load values over here, okay. Next go in the analysis of print, all, add, close. Now perform the analysis, select all, assign. Now go in the analysis, run analysis, okay, 0 errors, 9 warnings, doesn't matter for the warnings. Now you can go in the post processing mode, apply and okay. Okay, so in this way you can check out here the reactions at the support 50 kilonewton over here and minus 35 kilonewton. Here roller supports only one reaction, here in support as there is no horizontal roll, so X reaction is also 0, minus 35 and 50. Then considering any beam, if you considered any beam, then you will get the property, its shear bending as well as the deflection, then the loading over here, then properties. So here you will get the Fy and moment values. Similarly at different distance intervals you will get the values of reaction and the moment. Okay, now here also in reactions, in forces you will get this. When you are selecting this beam, here that row will get highlighted So in this you will get this reactions in x direction in y direction. So therefore total reaction you can calculate it under root of summation of fx square plus summation of fy square, that you will get the force in that particular member. Okay, similarly over here you will get this shear force diagram, right? Then the bending moment diagram. As here there is only point load, so bending moment diagram is a linear diagram, right? And shear force diagram is the constant line diagram, right? So in this way you have to analyze the trusses by using this StatPro. You can model any different type of truss in this StatPro, and then as per our usual procedure apply the supports and the load, and then perform the analysis to get the reactions or forces in the truss members. Okay, now you do the practice of solving different type of simple truss models. In the next video again we are going to see the analysis of some standard truss models. Okay, till that, thank you.